Hello everyone. Today we have another problem that is about the DC series motors. Today the problem is we have a 600 voltage DC machine as shown in figure 2 which also has 150 horsepower. At its full load it has a speed of 600 revolutions per minute. The armature field resistance, the armature and field resistance are 0.12 ohm and 0.04 ohm respectively. It has a 200 ampere current and we can assume it has a stray losses of 1700 watts. So the first part of the problem is that we need to get the armature back EMF at full load. Okay, to get the armature back EMF we will need to know the voltage supply, which is 600, our current, which is 200 ampere, our armature resistance 0.12 ohm, and our field resistance, which is 0.04. So let's put them all in the equation. So 600 minus 200 multiplied by 0.12 plus 0.04, which will equal to 568 volt. Now we solved the first part of the problem. What is the second part? He asked us to get the developed or mechanical power and the developed or mechanical torque. This is also hopefully pretty easy. To get the mechanical power, we will need to multiply the back EMF by the current. So we're going to multiply 568 by 200. This will give us 113.6 kilowatt. Now, to get the mechanical torque, we will need, we know that omega torque equals power. So, to get the mechanical torque, it's going to equal to power, mechanical power over omega, which is going to equal to, and we know that omega is 2 pi n over 60. So, it's going to be 60 times our power, which is going to be 113.6 kilowatt over 2 pi, 2 times pi times our n, which is speed, and the speed we have is 600. So this is going to equal to 1,808 Newton meter. Now, for part C, we can assume, he told us to assume that there's a change in our rod, which will drop our current to 150. He wants us to find the new speed in RPM, in revolutions per minute, and the new developed torque, which is the new mechanical torque. So now, to get the new speed first, we will need to get the new back EMF. So our back EMF is going to be 600. We have a new current now, so it's going to be minus 150 ampere multiplied by 0.12 plus 0.04, which is going to equal to 576 volt. Now, as we have back EMF 1 and back EMF 2, there is a rule that says back EMF 1 over back EMF 2 equals K flux times speed over K flux times speed. We have the K and flux as constants, so we can cancel them with each other. So the rule is going to be EB1, back EMF 1, over EB2, back EMF 2, equals speed 1 over speed 2. Now, we can say speed 2 equals back by cross multiplication, of course. So, back EMF 2 times N1 over back EMF 1, which is going to equal to 576 times 600 over 568. This is all going to equal to 608.5 RPM. Now, to get the torque, we first need to get the new mechanical power. Our new mechanical power is going to equal to 500 times 150, which is going to equal to 86,400 watt. Now we already know that the torque equals mechanical power over omega, so we can do this as follows. Our omega is 60 times 86,400 watt over 2 times pi times our new speed, which is 608.5, which will equal to 1,355.9 Newton meter. And that's all. Thank you for listening.